Right now, I'm going to go over a API 570 inspection report. This was not a typical standard API 570 inspection report. This report was for an out-of-service fuel pipe that was underground, and there was access to a pit, and they stuck a camera through about 150, 200 feet of pipe, and they scoped the inside of pipe just to get a general idea about the inside condition of the pipe. So as you see the limitations of just scoping a pipe, what you can get out of it, what you can't, you'll see the pictures of the condition of the pipe and what the purpose was. So I'll just get right into it. Here you got just the cover page. I blacked out some of the personal information, but we're talking about just a diesel fuel pipe that we went through and did the inspection on. As you can see, the second page of the report's a very short report, but you got your equipment. It was diesel fuel line. The inspection code was API 570 4th edition. Construction code of the pipe B311. You got the inspection date, about 200 linear feet of diesel fuel piping. It was an internal remote inspection. You know, you're at the pump room, you're under the pit, and you scope the pipe. You'll see where they stuck the camera into the pipe and where it goes underground. A 1995 construction of all this pipe. The tank it goes to outside. The materials of construction was carbon steel. It was about 6.625 outside diameter, pulling 6-inch piping, standard wall, class 2, 10 years, 183 design pressure. Ambient temperature, you got your thermal relief set at 90 psi. Then they give your guidelines for visual frequency of inspections, 5 years, and then if you want to take UT thicknesses on the pipe, 10 years. Basically, they said it was out of service inspection using the 570 guidelines due to lack of accessibility, severity and locations of internal corrosion and scale. Complete removal of sludge or corrosion and scale during inspection was not possible at the time. So when they stuck the camera in, at points it was very hard to see because there was sludge, corrosion, a little bit of fuel sitting there, so you didn't get a clear picture at all times. As you can see, they used a push rod camera, a Pierpoint model P374IS. Then you got the date. Fuel pipe was diesel. We're trying to capture the internal condition of a buried pipe system. There was no information on the pipe. This particular location had very high water table, so most of the time these pipes were drenched in water, and whether the cathodic protection was installed right is not known. They had a filter separator that was not used for a very long time. They just started using it within 10 years. Like I said, the water tables were high at this level. Overall pipe integrity was in question, so they kind of did a little bit of a remote internal inspection. It's 95% carbon steel with a little bit of stainless steel at certain points. There's pressure relieving devices that were not tested all the time and lacked tags and the proper documentation. The above ground pipe was painted and uninsulated with various support components, and just giving you an overrun of the conditions of the pipe, which he inspected. Okay, here we go. We're back in business. But it was above ground, about 200 feet. Carbon steel pipe was inspected. You'll see in the pictures welded and threaded connections at various locations. No major defects were noted from the visual results, but uniformed internal scale with multiple layers was found. Random active internal pitting was found. You'll see these on the pictures in a second. Heavy residual sludge sagging in the pipe at various locations. General oxidation throughout the span, and then he gave his recommendations Consideration should be given to cleaning and re-inspecting areas for extent of degradation. Consider using guided wave examination where they shoot YouTube waves at an angle, and they could actually get kind of a picture, like a 2D kind of scan of the pipe by shooting these guided waves. And he's saying that this would give a more accurate representation of the condition of the pipe without having to excavate the pipe. So basically he's saying that if you want a better assessment of the pipe, use guided waves, and you can get the remaining life and establish corrosion rates of the pipe. Consideration should be given to removing all residual buildup, inspecting areas for damage. Consideration should be given to consulting with an engineer personnel to ensure adequate measures are in place subject process in regards to chemical agents and processing equipment. Consideration be given to civil engineer in regards to the water table and the below grade soil conditions. Consideration should be given consulting an engineer in regards to cathodic protection measures, protective wraps, coatings of the existing graded pipe. The extent of deflection, sagging should be assessed and evaluated. Consideration be given to cleaning and re-inspecting areas for corrosion using guided wave. So basically, when you're sticking a camera, you're very limited in what you see. The pictures are in, I believe, the next page. Here he's talking about thickness using API 570 and API 574. Inspection logic. The readings should be obtained from echo to echo techniques for coated components. API 570 radiographic profile techniques are preferred for pipe diameters 1. So we're not dealing with that small of a pipe. And just giving minimum thickness readings. There was no thickness readings on that, so it's kind of irrelevant to this particular inspection report. So this is what we get when we put a camera into the pipe. Here you see the scale and oxidation of the pipe. You see pits along the bottom of the pipe, just general oxidation. You see a little bit sagging areas in the pipe, oxidation, and little pits here and here. More general sagging, oxidation, pitting, general scale. So you see the inside of the pipes are pretty scaled, pretty beat up. You can't really get more of a qualitative assessment of it without doing the guided wave, as he said. More pipe pictures, general scale and oxidation, oxidation and pitting, general scale and oxidation, general scale and oxidation. These are all different points of the pipe to the tank. And finally, this is the last page. This, you can see this pipe was out of service right here. They went and stuck the camera through here and pushed the camera through this pipe, through this bend, and into the underground section. And this pipe ran all along this line, up through the concrete, up all the way back to the tank, about 200 feet of pipe away. So they did this on both the lines. No major defects were found, but since it's such a limited inspection, they couldn't really give you a qualitative results or number-based results. I'm sorry, I should say. Then the piping inspector would sign it and put his API cert in it. But the reason he did this is just to generally show that these pipe, because it was sitting in water for such a long time, is rotting away, and to get funding to go ahead and replace this pipe, which has been planning on replacing it anyways. So there you have it, just a little quick API 570 inspector's report for a push camera going through 200 feet of pipe. And the point was just to get some pictures so they could go show the people budgeting for this, look, this pipe's in bad shape, this design is not good, let's get rid of this pit and let's go with above ground piping and try to get a budget for it. So pretty much that's what we have for this AP 570 inspection report. I plan to put more on this channel, get more in inspection, get more into fuel systems, get more into the components. If you like it, subscribe, I'm trying to build my numbers up so eventually I can maybe do some live streams, questions and answer sessions, and connect with more people in the field. So go ahead and like and subscribe to the channel, and I thank you until next time.